Hello, welcome to pre-algebra. Today we are going to be looking at the circumference, surface area, and volume of a sphere. Now, if you remember from some of our previous lessons, the definition of a sphere is all of the points that are equidistant from one point. We call this one point the center. So it sounds really similar to the definition of a circle, but if you remember, the definition of a circle is all of the points that are equidistant from one point that are in one plane. So the difference is a circle is a two-dimensional figure, whereas a sphere is a three-dimensional figure. So sometimes spheres can be difficult to visualize or to work with, but if you think of any of these examples on the screen, a basketball, a disco ball, the earth, a Christmas ornament. A tomato is not a perfect sphere, but it gives you the approximate shape, or maybe an apple or a bowling ball. Any of those things are spheres, and they can help us visualize what a sphere is, because they are all three-dimensional objects. Okay, so the first thing that we want to look at today is the circumference of a sphere. Now, if you remember from before, the circumference of a circle is defined as the distance around the circle. It's kind of like a perimeter, but we just call it a different name when we talk about circles and spheres. So the circumference of the sphere is going to be the same thing. It's going to be the distance around the outside of the sphere. Now, it's a little bit trickier with a sphere because if we talk about the distance around a sphere, we could be talking about, for example, this distance right here. If you can kind of visualize, and then it goes around behind the earth there. Or we could be talking about this distance, kind of near the equator. Or we could be talking about maybe the distance around one of the poles down here. Okay, all of those distances are different. So which one is our circumference? Well, when we talk about measuring circumference, we have to talk about the distance around a sphere that goes through 2 points of a diameter. Now remember, the diameter, if we find the center of our circle, so let's pretend like this is the center of our circle. Okay, again, I'm approximating. I didn't measure that perfectly, but that's the center of our circle. The diameter is any line that goes through the center of our circle. So for example, this would be a diameter. Okay, this would be a diameter. This would not be a diameter because it does not go through the center of our circle. Okay, so if we go back and we look at these three circumferences for now, 1, 2, 3, which one would actually be a circumference? 2, right? Because that circle that I drew around the outside of the sphere in the second circle that I drew, that goes through 2 points on a diameter. Okay, so when we talk about the circumference, we have to make sure that we are going through 2 of the endpoints of a diameter. All right, make sense? Let's clean up this picture here a little bit. Okay, so now that we've defined what circumference is for a circle, or for a sphere, we have to figure out, how do we find it? Well, if you remember, the circumference for a circle is found by using 2 pi r. And we're going to do the exact same thing for a sphere. 2 pi r. Remember, pi is just a symbol that stands for the number 3.14159, and it keeps going on forever. For our purposes, we're going to approximate pi to 3.14. Okay, so let's look at the first example. The first example says Earth's radius is 3,959 miles. Find the Earth's circumference. Okay, so let's draw a little picture here. There's my radius. My radius is 3,959 miles. I want to know the circumference. So I'm looking for the distance all the way around. You're kind of going to have to bear with my drawing here, okay? I'm looking for that brown line, the circumference. Well, we know that c equals 2 pi r. Let's start there. Do I know my radius? Sure I do. They were nice enough to give that to me, 3,959 miles. Okay, so then all I have to do is take 2 times pi, we said we're approximating to 3.14, times 3,959. 2 times 3.14 times 3,959. Got your calculators? Okay, so the circumference is 24,862.52 miles. Okay, so if you were to travel all the way around the Earth, you would be going 24,862.52 miles, approximately. Okay, these are approximations because obviously some parts of Earth are higher or lower, and so when we're measuring the radius from the center of the Earth to the edge, it's an approximation, and pi is also an approximation. All right, let's go on to the next example. Example 2, it's talking about a tennis ball. It says the circumference of a tennis ball is 8.25 inches. Find the radius. Okay, so here's my tennis ball. Circumference, again, is a distance all the way around, and that distance has to be measured through 2 endpoints of the diameter. So there's my circumference, 8.25 inches. I want to figure out the radius. Okay, so I put this picture of a sphere on there, right here, just in case we wanted to kind of get a better picture of maybe the inside of a sphere, help us visualize a little bit more. So again, the radius is going to be from the center. The center's inside a sphere. Okay, so there's the radius. Right there. And our circumference is going to be all the way around the outside. And we know our circumference is 8.25 inches. So just another way to look at it. Okay. We're looking for a radius, so I'm going to name the radius r. And again, I'm just going to start with our formula for circumference, 2 pi r. Okay. This time, do I know my r? No, that's what I'm looking for. So I'm going to have to keep r as r. But I do know my circumference. That's 8.25 inches. Okay, so we're going to have to use a little bit of algebra here. Again, pi is just a symbol that stands for a number. So pi is just 3.14. So maybe we should just replace that. Might be a little bit easier to see. Okay, so 2 times 3.14, that's going to give us 6.28. And to solve for r, I'm just going to divide both sides by 6.28. Again, we're going to need our calculators. Take 8.25, divide it by 6.28, and I am coming up with, we'll just round to 2 decimal places, 1.31 inches for that radius. Okay. So if I were to find the center of a tennis ball and draw a line to the outside edge of a tennis ball, that radius would be 1.31 inches. Okay, the rest of the lesson we're going to talk about finding the surface area of a sphere and also finding the volume.